Hi everyone, let's look at today's topic, which is permutations. What is permutation? In English, plain English, the meaning for permutation is each of all possible ways in which a number of things can be arranged. And mathematical meaning of that is very close. A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So let's get into some problem solving and then see how we can understand this. Before we jump into that, there's a concept which we need to familiarize ourselves with, which is factorial. What is factorial? Let's say 5 factorial. This is read as 5 factorial, and it's the digit 5 followed by an exclamation mark, which is expanded as 5 times 4 times 3 times 2 times 1, and 4 factorial is represented as 4 times 3 times 2 times 1, and say 8 factorial, that is expanded as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I have not given the actual answers because we are more interested in finding out what is the expanded form of the factorials. In generic form, this can be written as n factorial, which is equal to n times the number previous to that, n minus 1, and the number previous to that times n minus 2. It goes on up to 1. We will be using this concept in solving permutation related problems. The first method that we are going to look at solving permutation related problems is called as box method. Mainly, this is not the official name, but because we will be using a lot of boxes, that's why this is called a box method. Let's go to the first question. How many 3-letter words can be formed from the letters C, A and T, and repetition of letters not allowed? Say we write down the letters C, A, T. We are going to arrange these 3 letters in possible ways. So these are the ways in which we can arrange it: CAT, CTA, ACT, ATC, TAC and TCA. So totally we have 6 ways in which we can arrange these letters. And what repetition of letters not allowed, meaning we cannot write CCC. So C cannot be repeated, or any of the letters that are here that cannot be repeated here. Now, using the box method, how can we find out the answer? Since it says it's a 3-letter word, so we have 3 boxes, and the number of letters that are taken at a time is 3, and the letters available are C, A and T. Now for the first box, we have to choose one of these letters here. And how many choices do we have? We have 3 choices for filling up the first box. For the second one, since it says repetition of letters is not allowed and 1 letter has already been used here, so the number of choices we have is 2. And for the third one, since 2 letters have already been chosen, we are left with 1 choice. So the number of ways in which we can arrange the letters CAT is 3 times 2 times 1, or it can be represented as 3 factorial, which is equal to 6. Now to verify that, we can look at what we have manually written down here, all the possible variations of C, T and A, the 3 letters. So we have got 6 here, and using the box method we have got 6 as well. Now how many 3-letter words can be formed from the letters C, A, T? And one small change: repetition of letters is allowed in this case. So we are using these 3 letters, and in this case, in addition to 1, 2, 3, 4, 5, 6 ways of writing them, we will have additional ways of writing them, because we can have words like CCC, TTT and AAA and so on. So when we write them, we get a total of 27 words. That is the total number of ways in which we can write or arrange the letters C, A and T when repetition of letters is allowed. For example, we have TAA, A is repeated here twice, and CTT, T is repeated here twice, C is repeated here, and so on. We also have TTT as well. So all these permutations are here, and the total number of ways in which we can write these letters is 27. So now let's confirm that with the box method. Since we say it's a 3-letter word, we have written 3 boxes, and for the first box we have to choose one of these, so it would be 3. We have 3 ways of choosing one of these here, and for the second one also we can choose one of these 3 because repetition is allowed. So in this case it's 3, and for the last one also the available choices are 3, so we have 3. So the total number of ways in which we can write the letters or arrange the letters C, A, T is 3 times 3 times 3, which is 3 to the power 3, and that is equal to 27. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of digits is not allowed? So here again we need to form 3-digit numbers, and from where do we find these numbers? We have to take it from 1, 2, 3, 4 and 5. So the available digits are 1, 2, 3, 4 and 5. From these we are going to take 3 at a time. So we have 3 boxes here. The first box can be filled up in 5 ways, so that's 5. And since repetition is not allowed, once the number has been filled up here, that cannot be reused, so we'll be left with 4 digits for the second box here. So that's 4, and the last one will be left with 3 digits. So the number of ways in which we can write 3-digit numbers from these 5 digits is given as 5 times 4 times 3, and that is equal to 60. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of digits is allowed? So in this case it's the same as what we did in the previous question. The only difference is the condition which says repetition of digits is allowed. So we write down the number of digits that are available, 1, 2, 3, 4 and 5, and since it's a 3-digit number we have 3 boxes, and for the first box we have 5 ways of filling up the first box. We can fill it with 1 or 2 or 3 or 4 or 5. So that is 5 ways of filling up. The second one can also be filled up in 5 ways because repetition of digits is allowed. Even though I fill this with a number, I can still reuse that here. So the number of ways I can fill this up is again 5, and the number of ways in which I can fill this up is 5 as well. So the number of ways a 3-digit number can be formed, or the number of 3-digit numbers that can be formed, is given by 5 times 5 times 5, which is equal to 5 cube, and that's equal to 125. Now if we look at closely, there is a generic formula that we can derive for these kind of problems where repetition of digits is allowed. It is n to the power r. N represents the number of digits available, and r represents the number of digits that are taken at one go. Here it is taken at 3 is taken at one go, and the number of digits is n, so n power r, which is the same as 5 cube. 5 is the number of digits that are available, and 3 is the number of digits that can be taken at one time. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 57 and no digit appears more than once? So we need to form 5-digit telephone numbers. First, based on 0 to 9 digits, so let's write down the digits that are available for use: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And with this we are going to take 5 at a time, or 5-digit telephone numbers. 1, 2, 3, 4, 5. We are going to form 5-digit telephone numbers using these 10 digits. And there is an addition condition. Each number starts with 57, which means these two numbers, this is 5 and this is 7, these two are fixed. We cannot change it, which is totally beyond our control, so we are now focused on only these three, filling up these three, and this box can be filled up in how many possible digits do we have, because 5 is already used up and 7 is already used up, and because the condition says no digit appears more than once, it means no repetition. So for this one, the choices we have are 10 minus 2, 8 available choices. So 8 ways in which we can fill this box, then followed by 7 ways we can fill this box, and followed by 6 ways in which we can fill this box. So the number of these two are fixed, so they do not participate in these here. So the total number of ways in which we can form 5-digit telephone numbers, and where the digit starts with 57 and no repetition, is 8 times 7 times 6. So that is 336. Now we can look at the permutation formula. We used a method called a box method, which is kind of an unofficial method. So now let's see what is the official method that is available for solving permutations. How many 4-digit numbers are there with no digit repeated? First, we write down the available digits. So we have digits from 0 to 9, because it doesn't say where we have to take, so we assume that we can take all the digits available, and it's a 4-digit number, so we have 4 boxes here. Now the first box can be filled in 10 ways. The second box can be filled, because it says no digit repeated, it has to be filled in 9 ways, and followed by 8 and 7. So the number of ways in which 4-digit numbers can be formed is 10 times 9 times 8 times 7, which is equal to 5040. This is the box method that we have used so far. Now if we are using the formula method, the formula for permutation is n factorial divided by n minus r factorial. In this case, n is the number of digits available and r is the number of digits that we take at a time. So here 4 digits are taken at a time to form a 4-digit number. So n factorial divided by n minus r factorial is equal to 10 factorial, which is there are 10 digits available, divided by 10 minus 4 factorial. That gives us 10 times 9 times 8 times 7 times 6 factorial divided by this is 6 factorial. I could have written it fully, but since I know that the denominator is going to be 6 factorial, I leave it here so that I can cancel them off easily and just multiply the rest of them to find the answer. How many 4-digit numbers can be formed with the digits 1, 2, 3, 4 with no digit repeated? So available digits 1, 2, 3 and 4, and we are taking 4 at a time, or we are forming 4-digit numbers. So the first one can be filled up in 4 ways, second one can be filled up in 3 ways, third one can be filled up in 2 ways, and the last one filled up in 1 way. So the number of ways in which 4-digit numbers can be formed using the digits 1, 2, 3, 4 is 4 times 3 times 2 times 1, and that is equal to 24. Now let's do the same using the permutation formula, which is n factorial divided by n minus r factorial. So here n is 4 because there are 4 digits available, divided by, and here it's interesting here, see this 4 is equal to n because it's the number of digits, and r is the number of digits that are taken at one time, or the number of digits for forming this, that is also 4. So this will become 4 times 3 times 2 times 1 divided by 0 factorial, and there is another interesting fact here, it becomes 24 because 0 factorial is equal to 1. Why is beyond the scope of today's discussion. We will try to look at it another time, but just remember that 0 factorial is equal to 1. So we get the same answer here as what we had got there. how many 4-digit numbers are there with no digit repeated. This again, the total number of digits available is 0 to 9, and we can write this as 10p4. So permutation formula, one of the ways in which we represent permutation is 10p4, which means available 10 digits, and we have to form 4-digit numbers. So at a time we are going to take 4 of them, right? So this is exactly equal to 10 factorial divided by 10 minus 4 factorial, which is of the form n factorial divided by n minus r factorial. So in this case it is 10 times 9 times 8 times 7 times 6 factorial divided by 6 factorial. We cancel off the 6 factorials from the numerator and the denominator and multiply the remaining to get 5040. What is permutation? The formula, the number of permutations of n different objects taken r at a time where repetition is not allowed is given by this formula, npr equals n factorial divided by n minus r factorial. So that's the formula for the number of permutations of n different objects taken r at a time and where repetition is not allowed. Now, number of permutations of n different objects taken r at a time where repetition is allowed is given by this formula, n to the power r. You can just go back a few minutes. You can find that we have established this formula in one of the problems that we have solved. Let's just review the concepts that we have learnt so far. We have seen the use of box method for problems where repetition is not allowed, and we have also seen the box method for repetition being allowed. And the permutation formula, the number of permutations of n objects taken r at a time without repetition is npr equals n factorial divided by n minus r factorial, and number of permutations of n different objects taken r at a time where repetition is allowed is n to the power r.